According to Bernard Marr, there are 2.5 quintillion bytes of data created every day. With 156 million emails sent, around 47,000 new Instagram posts, and 3.6 million Google searches each minute, parallel computing is all around us. Parallel programming is a type of computation in which instructions are broken into subprograms and executed concurrently. Now, for some context, serial programming was more mainstream in the early days of computing and consists of a series of instructions that is executed one by one. As you can see, parallel programming allows the program to divide and conquer in a sense, because each subgroup is being processed simultaneously with different processors, like CPUs. On the other hand, if we take a look at our serial programming diagram, we can see that only one piece of instruction can be processed at a time, which can really slow us down. Not only is parallel computing more efficient, but it is also capable of solving larger problems, which is useful in fields such as data analytics, where large, consistent amounts of data need to be processed. Exploring parallel computing's role in data analytics, we are going to look at a programming model called MapReduce. MapReduce is a feature on Hadoop. Now, Hadoop is a big data ecosystem that processes big data. The data that companies accumulate from various data resources is of great volume and implies parallel computing, since the data must be distributed across different CPUs in order to be processed in a reasonable amount of time. The MapReduce framework has two main functions, to map and to reduce. The map function processes the input data, which usually comes from Hadoop's distributed file system. The tool will first take an input pair and produce an intermediate key-value output, the pairing of which will depend on how the user has written the function. In between the map and reduce functions, there are intermediate steps. Similar instructions or partitions of data are shuffled, sorted, and eventually ready to be fed into the reducer. Now, for the reduce function, the reducer will accept our intermediate keys and merge its values together, and its goal is to form a smaller set of values. As mentioned earlier, parallel programming is now the mainstream framework. Let's take TikTok, for example. TikTok has developed an algorithm to ensure that their users' For You page consists of videos they're interested in. TikTok collects users' likes, hashtags, people they're following, and so on, and they split up this data in order to process it all at once, using your engagement on the app to come to a decision on what types of videos you like. There you have some of the basics of parallel computing and a few examples of when it's applied.